All right, Algebra 1, we are back. All right, let's move into Section 4 today, Chapter 3, Section 4, titled Equations with Variables on Both Sides. All right, so we're going to have some moving to solve these problems. All right, everybody have your textbooks open to page 146. All right, get there. Have your notes right there with you. That way you guys can get through this video and get everything important to learning section 4. All right, so let's get into our notes. So first thing, step 1, get the variables on the same side. So that means you're going to have to move one of the variables, and if it has a coefficient, you know that coefficient goes with it. Okay, then get all the constant values on the other side. So if you have variables that you're moving and variables are all going to go to the left, that's great. But then get all the constant values and move those all to the right. Okay, that way you have a full separation, variables one side, constant values on the opposite other side. Okay, and this piece is important. All right, if we do this wrong, the whole problem is going to be wrong. Never forget, just as it says, when you move a term, that means a variable or a constant. That's just what terms are. If you move these terms across the equal sign, that basically means if you move them from the right to the left, or if you move them from the left to the right, the sign on that term will change. Okay? And then take a look at the little example that I give you there. So if I were to have 2x minus 4 equals 3x plus 5. I want to get that 3x, and I'm going to move it to the left. Okay, that's fine. I'm going to take that negative 4, and I'm going to move it to the right. That's fine. But notice the sign change. 3x was a positive. When I moved it, it became a negative. Okay, take a look. Sign change right there. That original negative 4, that was a negative. Move it to the right. Notice, take a look. It's now a positive 4. So notice the sign change there. Okay. All right, let's move into our last little note here. It is possible to cross out your variables completely, meaning you can actually eliminate x from an equation, and x is completely gone, or y, or whatever letter they're using. Then, if that is the case, you will have one of two answer possibilities. One is you could have all numbers, meaning that any number you plug into the original equation will work. Or you could have no solution, meaning it doesn't matter what you plug in, it won't work, it's not possible. Now, if you take a look at example 4 on page 148, you'll see the book's example of this. But if you follow me closely, the examples we have at the very end of this video will cover this note right here. All right, now something that I do want to reference, if you remember in the last section, we talked about how do you eliminate a fraction if that fraction is in front of the parentheses. All right, hopefully you remember you would multiply both sides by that fraction's reciprocal. But in this section, there's something different. In the last section, you were multiplying just a single term by that reciprocal fraction. But in this section, you wouldn't do that. All right, so we're going to do a problem that has a fraction, and we're just going to take that as it is, meaning we will distribute the fraction, and you'll see how that works out. All right, let's do some example problems. Here we go. First step, what do? Get all the variables on one side, get all the constant values on the other side. Okay, so I will tell you, it doesn't matter what side you choose to move them to, but just pay attention to the signs. All right, so it doesn't matter. I could take a negative 2x and move it to the left, or I could take the negative 3x and move it to the right. It doesn't matter, but pay attention to the signs when you move. So for this, I'm going to take that negative 3x, I'm going to move it over, I'm going to take that positive 17, I'm going to move it to the other side. So let's rewrite. I now have 9 minus 17 equals Now a positive 3x minus 2x. Pay attention to your signs as you move. They become the opposites. All right, now combine like terms. So I have a 3x minus a 2x. That's pretty nice here because that is just going to give me x. And then I have a 9 minus a 17. Okay, and that's going to give me a negative 8. All right, negative 8. Okay, that's as far as we go there. Perfect. The 3x minus the 2x, that really helped because that dropped it down to just x. So we didn't have to worry about any division at the end of this problem. Okay, let's move into our second example, which now you will see clearly a fraction outside of a set of parentheses. Any number that's connected to a set of parentheses means you will use the distributive property. With a fraction, you still use it, but you got to pay close attention because we are actually distributing a fraction in and multiplying both of those numbers, 6x and 15, by 2/3. Okay, so I'm going to write this just so you can see the full process over to the side. 2/3 multiplied by a 6x. I'm going to put it over 1. So that's going to give you a 12x over 3, which when we reduce that down simply gives you 4x. All right, so that's what we have here, 4x. Then we have the second part, 2/3 multiplied by 15 over 1, which gives you 30 over 3, which when you simplify that down simply gives you 10. So we're going to say plus 10. All right, now I'm not saying you have to show all of that, but I think some of you guys really should because you may have difficulties working this out in your head. You may immediately say, I see a fraction and I freak out. Don't do that. All right, take a breath and work it out one step at a time. Showing your work, guys, is really helpful in terms of honestly calming your brain down because you're writing everything out. You don't have to have your brain memorize a step and then, oh, recall that step and multiply it later. Just write it down and show your work. It will be easier. Okay, we took care of the fraction, so that's perfect. Let's write the other side, 8x minus 6. Now we need to move things around, okay? So I'm going to take the 4x and move it over here. I'm going to take a negative 6 and move it over here. And now we need to rewrite it, but pay close attention to the sign changes. 8x did not move, but the 4x did. It's now a negative 4x. Okay, the negative 6 moved to the right. It's now a positive 6 plus 10 because that plus 10 did not move. All right, still there. Now, let's see what we have. Go over here. And 8x minus 4x giving us 4x. 6 plus 10 giving us 16. All right, and how do you get rid of that 4? How do you isolate the variable? Divide by 4 on both sides. So x equals 4. All right, sorry, I kind of ran out of space there. I think we're still okay. Follow the work all the way down. All right, let's do example 3. So we will start by distributive property. All right, I got a 9, distribute, 9x plus 27 equals 9x plus 12. All right, here is a red flag moment. Pay close attention. Your brain should immediately be cluing into something, or at least now it will start to clue into something. Here's what it should clue into. You see identical terms on both sides. I got a 9x on the left and a 9x on the right. If you see that, that means that you are about ready to cross out your variable, meaning eliminating x. X is gone completely. Okay, why will that happen? Because it doesn't matter what side I move 9x to. I'm going to get 9x minus 9x. meaning it's gone, eliminated. So that means these guys will cross each other out. What do I have left? I have 12 equals 27. That's not true. 12 can't equal 27. They're not the same number. So this is an example of a problem where your answer is no solution. In other words, plug any value into x that you want, you will never get a correct solution. It will never work. So number 3 there, that's an example of no solution for your answer. All right, let's do number 4 here. Okay, again, start, distribute, distribute. Looks like I got to do this to both sides. Distribute, distribute there. 3 times 2x, 6x. 3 times 2 plus 6. All right, 2 times 3, 6x. 2 times 3 plus 6. Whoa, another big red flag moment. You guys should see some stuff here, except this time you should see I got 6x on this side and another 6x on that side. The x's will disappear. All right, I'm going to eliminate the variable, but something else, 6 and identical 6. What did we see here? Both sides are identical, 100% identical. So what does that mean? That means you will now get an answer of all numbers. This means whatever you plug in for x, doesn't matter what the number is, it will always work. Any value plugged in for x will work. So your solution here is all numbers. That's what you have to write. Okay, that's it, guys. That's all I got for you. That is our last example problem here for section 4. So keep working hard. Stay motivated. All right, I'll see you guys in the next one.